All right, so before the break, we just introduce, review how the function works, right? We take the input like -2 and then put into f of x, you get an output of -3. So I already mentioned that inverse, we'll try to do the opposite. Okay, we take the output, which is -3, and we'll try to somehow get the input back. Okay, so we want to put -3 into the function, a new one. Okay, so then your output will become -2. Okay, so used to be output, now it will become input. Right, -3 used to be output, now it is input. Right, and then -2 used to be input, now it becomes the output. So of course the function will look different. Okay, so before was 2x plus 1. Now we want to go backwards. Okay, so there's a few steps, right, you can do to figure out that function. Okay, step 1 is to rewrite f of x as y, right? Because it's easier to just work with one letter. Okay, instead of f of x, we just write it as single letter y. So I'll show the step on the right hand side. Okay, so here's the question, right? F of x is 2x plus 1. So your step 1 is to rewrite this part. Okay, write it as y. So that's what it means. Okay, write f of x as y. So if the question already has y, then you don't have to do step 1. Okay, after that, okay, step 2, because to find the inverse means you reverse, right? You flip the x and y, right? Used to be x, now become the y. Used to be y, it becomes the x. So step 2 is to switch x and y variables. Okay, so original you have y on the left side, now it becomes x. Okay, change the letter. Right side will be 2y plus 1. So the moment that you do this step, this is already called the inverse. Right? Because you already flipped it. Okay, I already inversed it. Okay, but then keeping it in this form, it's very difficult to sub it in and find the output, right? Because I would have to put -3 into the left side and then try to solve for y. Okay, so that'll be difficult to use. So that's why we need step 3. Okay, we need to isolate the y. Okay, because usually we like to have y by itself. All right, so step 3 is to isolate y. So I want to keep y by on one side. How do we start? Eric, how do we isolate y from here? Eric, you should be back, right? Yeah.
Yeah. I'm not sure. Do we just like flip it again?
No, we don't want to flip it again. We just flipped it, right, to make it into inverse. Right now, the y is right here, right? You see the underline, right? Y is there, Eric.
Yeah.
Okay, you want to keep that part alone, right? Isolate. So which part should be moved to the left side?
Oh, does it become x minus 1 over 2?
Yeah, okay. So we can move the +1 to the left. So become x minus 1. Okay, and then divide both sides by 2. So then the y will be alone. Okay, so now the new form, which is y equals x minus 1 over 2. This one is called the inverse. Okay, both of them are inverse. But then the second one is easier to use, right? Because usually we want to plug it in, right? Plug in the x, find the y. So the y needs to by itself, okay? And then the symbol for the inverse is we write it as Let's write it here. Okay. F with a little -1. Okay, so that -1 is not exponent. Okay, please remember that it's not exponent. It's a symbol to represent its inverse. So inverse of x is x minus 1 over 2. Okay, so we use a different symbol so you can see right away this one's the inverse, right? Otherwise, everything is x and y, right? You don't know which one's original, which one's the inverse one. Okay, so we have original is right here, inverse is down there. Okay, so we found our inverse. So in the homework, they will say, please find the inverse. These are the 3 steps you need to carry out. Okay, do you have any questions so far? Can you raise your hand if you understand everything up to here? Okay, very straightforward. Just carry out 1, 2, 3. Okay, Lily and Susan, do you have questions about the 3 steps? Okay, everyone good? All right, so let's test it out, right? So here's our function, right? We want to see if it works. So we can do is we plug in -3, right? If we, for example, right, I'll do on the top. Oh, 1 sec. Okay, so for example, if I plug in -3, right, into the function that we just found, it'll be -3 minus 1 over 2, right? Because x is -3 now. -3 minus 1, -4, right? -4 over 2, give you -2. And we want that, right? I put -3 in, I get -2 out. Okay, let's try another one, see if it works. So let's say I plug in -1. Okay, so it will be f of -1, f inverse of -1. Right, so Nick, how do I put it in?
So you basically substitute x for -1.
Yeah, how do I write it out?
So -1 minus 1 over 2.
Yeah, becomes?
And it becomes -2 over 2 or -1.
Which is -1. Yeah, okay, so it matches again, right? So yeah, I take -1, put it in, it still gives you -1. Okay, so the mapping works now. Okay, and so on. And so that means the points, once you know the table for the original, then the table for the inverse will be just flipped around. Okay, so we can go to our table now. Let's give different color, okay, for each, because we're going to graph it. Okay, for the original, I'm going to use red. For the inverse, I'll use the green. Okay, so first point for inverse will be -3, -2, right? Flip the x and y. Okay, can you raise your hand one more time if you finish the table for both of them? Okay, I don't want to go too fast so that some of you falling behind, okay? So please raise your hand if you finish writing down both tables. Okay, all right, so let's grab them, all right? So for the inverse, we'll use the green color, right? If you have 2 colors, you can use that. It will be easier to read it later. For the original, I'll use red, okay? So -2, -3. So that's our first point. For the original, -1, -1 will be here. 0, 1, right? So you can start to see the pattern, right? There's a straight line, right? Has a slope. Okay, so connect that. So get a ruler out and make sure you label it. This one is f of x. Okay, now let's grab the inverse. Inverse x and y switched. So -3, -2, -1, -1. Okay, so that one overlaps, right? 1, 0. Okay, and then we see the pattern. Okay, so connect. And label F inverse. Okay, please raise your hand if you finish the graphs. Okay, raise your hand if you're done the graph. All right. Okay, so what you can see from here is they kind of like has a connection between them, right? If we try to draw a mirror line, okay, like a symmetry line, where would you draw it so it's symmetry? Lady, can you like try to draw on the screen and then show us if I try to make a mirror line, symmetry line, where would you draw it?
How do I do this?
You can use annotate on your there should be a function, annotate, and then you can draw on the screen.
Um,
Can you find it?
no.
You're using the computer?
Yeah.
Yeah.
On
Okay.
the options on the top.
Oh. Can you repeat the question again?
Yeah. So I will let you see the red line and the green
Yeah.
line, right? So if I try to draw a symmetry line, where would you draw it? So then each side of the symmetry line, you have the same picture. Do you understand my question?
Yeah.
Yeah. Okay. So can you draw the symmetry line for the graph?
Does it have to be like straight, like vertical or horizontal? Can it be like diagonal?
Yeah, could be any way as long as it's a symmetry line.
Oh.
Yeah, very good. Very good. Okay, good. All right. So if I split the way that little did here, right? I cover one side, right? For example, oh, what's happening? Where did it go? It jumped the page. Okay, let me see, where did it go to? Okay, here we are. Yeah. So here's a symmetry line. Somehow it got so huge. Okay. So if I cut it right in the middle, then the upper left will look like the lower right. Okay. So that's a symmetry line. So in fact, for all the inverse, the symmetry line will always be the same. Okay, so I'm going to use dotted line. Okay, so you can also put it on your screen, on your paper. Okay, so this blue dotted line is the symmetry line. So if you look at the points on the symmetry line, you have X and Y points are always the same. For example, like this one is 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, right? Same with the other side. Okay, it goes through the middle when the X and Y are the same. So that equation line is called the Y equal X. Okay, it has, if you remember the slope y-intercept form, right? Y equal mx plus b. This one has a slope of 1 and b of 0, okay? Mx plus b. Okay, so we have a symmetry line. Symmetry is y equal x. For any original and inverse function, always have symmetry line. So that's one way you can check if your graph is correct or not. Okay, you draw a line and see if they are symmetrical. Okay. So any questions so far? Okay, now if you go back and look at the box on the top, okay, it should make more sense. So let's read that through again. Okay, so given y equal f of x, so this one is the original, right? I give you an original function. If the value of x and y are switched, right? So remember, inverse means you need to switch x and y. Then the new function is called the inverse function, right? Make sense, right? We just covered that. The symbol for that is this, right? F with the -1. So remember, the -1 is not exponent, okay? So do not confuse that with the exponent. If they want to show exponent, right, -1, they will do it like this. F of x to the -1, okay? Then this one is the exponent. If they put the -1 in between, right, between the f and the x, then that's the for inverse, right? So make sure you be careful. And the next part is talking about the graph, right? We just covered that. The graph for the original and inverse will reflect over the line y equal x. Okay, so for you to check. So this is a diagonal line. Diagonal. Okay. So that's all you need to know, okay? For inverse, we're gonna try a different one, okay? So each time you will be given a different original and you try to find the inverse. Okay, so step 1, write f of x as y. Step 2, switch x and y, and then you need to isolate y, right? So I'll let you try this one. So don't worry about the graphs yet, okay? So just figure out the inverse first. We can do on the side, okay? F of x equal root x plus 3, and then do step 1, 2, 3. I'll let you try this one by yourself, okay? Go as far as you can. This one has a square root, so it might be a little bit difficult, okay? But it's possible. So when you got the inverse, you can raise your hand. You just follow the steps on the top, okay? Once we got the function for the inverse, we'll talk about how to graph it, right? And this one is a square root. Radical function.
Oh, Jason, I just want to remind you, I have to go now.
Yep, okay. I'll see you next week, Marcus.
Bye.
Bye. Okay, let's check step 1 first. Right, everyone should get step 1, right? So Eric, what's step 1?
We flip the x and y,
Nope,
I think.
not there yet.
Or no, it's a y equals x plus 3, right?
You forgot the square root.
Yeah.
Okay, step 1, you need to write it as y. Okay. Okay, Evan, step 2, what is it?
Switch the x to the y.
How do I write it out?
So it becomes x equals square root y plus 3.
Yep, very good. Okay, so if on the multiple choice, right, let's say you got a question, they want you to find the inverse. And on the option A, B, C, D, right, one of the option is like step 2. Then that is also correct, okay? Even though they did not isolate y yet, right, it's still called an inverse. It's just not in a form that we like, right? So the moment that you switch x and y, it's already an inverse. It's a different function. Okay, so please raise your hand if you already finished isolating the y. Right now the y is stuck inside the square root. Okay, so think about how can we get it out, right? Save the y. Okay, Sophie, how do we start?
I squared it both sides.
Can you say that one more time?
Squared both sides, not squared. I squared both sides.
Yeah, square both sides, very good. Okay, square will cancel out the square root. So it will be x, use the blue. So I will square the left and then I'll square the right. So you get x equal to y plus 3. Oh, square, right? And then what do we do now, Jocelyn?
I'm still working.
Are you on step 3?
Yeah.
Right, we square both sides already now, right?
Yeah.
Yeah, so we are only one step away. How do we isolate the y? Just last step, you can tell me right now.
I'm not sure.
The y is right now, the y is on the left side or the right side?
The right side.
Right side, right? So we don't want, we want to isolate the y, so which part we need to move over?
The x squared.
I want to keep the y on the right side. So which one doesn't belong to the right side?
The 3.
Yeah, so I want to get rid of the 3, right? The plus 3. How do we do that?
Change it to like a -3 and then move it over.
Yeah, okay, so we just grab the plus 3, move it over, and then change it to -3. Okay, so can you tell me what it looks like afterwards?
Sure.
Yeah, what is it?
X squared -3 equal to y.
Yeah, very good. Okay, so but we prefer to have y on the left. Okay, so I'm gonna rewrite it. Okay, and then also using the new symbol, right, to show that it's an inverse. So write it as f inverse of x equals to x squared minus 3. Okay, so this one is the original. Okay, original. And then this one is the inverse. Okay, I'll use the green color. Okay, so if you have a square root, this is how you can isolate the y. Okay, so now let's talk about the graphs. Chris, Eric, and Evan, are you guys done? Yeah, okay, so let's look at the graphs now. So we are trying to graph the f of x. F of x is called a radical function, right? So when you see a radical, right away you should think about restrictions. Okay, we talked about restriction today, right? How do we find restriction for a radical? Angela?
You mean for this one or just for like all radicals?
For all the radicals.
It has to be bigger or equal to 0.
Which part?
The x
Just the x?
plus 3.
Oh, for this one will be x plus 3. So in general will be everything inside the square root, right? Inside has to be greater and equal to 0. Okay, so everyone needs to memorize that. Very important. Okay, just like you remember denominator cannot be 0, just like you remember you cannot cross the road when it's red light. Okay, so x plus 3 has to be greater and equal to 0. So if we isolate the x, x will be greater or equal to -3. Okay, so that will be the rule for choosing your input. Okay, so unlike straight lines, right? The last question is straight line. You can use any input you like. But for radical, you have to be careful, right? I cannot use like -10. Okay, so I'll start with -3 and I'll get bigger. Okay, so -2, -1, 0, 1. Okay, so let's do that. So I'll let you guys figure out the output. Okay, so if it's a decimal number, then just leave it in square root. Okay, if it's not a perfect square, you can raise your hand when you finish the red graph. Okay, the original graph. Finish the table and draw the graph. Okay. So raise your hand when you've done both. Okay, the graphing and the table. For the original, we're gonna use red, okay? Just like last question. And then inverse, we use the green. Okay, please raise your hand if you finish the graph for the red. Okay, Callum, can you tell us your points? Callum?
Oh, sorry. Yeah.
Yeah.
The first one is -3 and 0.
Yeah. Go on.
The second one is 1.
Yeah.
The next one for -1 is like like a decimal number.
You can give me the square root. Square root of what?
Oh, square root of 2.
Yeah, very good. Next one.
Next one is just square root of 3
Yeah, next one.
and 2.
Yes. Okay, very good. Okay, so if you have the table, you should be able to complete the graph. Can you raise your hand if you all finished the graphs? All right, let's check the points. All right, so -3, the points are good, okay, the graph. -3, 0 will be here. -2, 1. -1 root 2. Square root 2 is about 1.4, right? 1.4 something, a bit higher, right? We can go to the 1, 2, right? Easier to graph that one, 1, 2. So we know it's a curving, right? Slowly curving upwards. So something like this. Okay, so now to graph the inverse. What's the best way to graph the inverse? Can anyone raise your hand if you know a good way to graph inverse? How can we get the points quickly to find the inverse graph? Anybody know? Any suggestions? Based on what we learned in the last questions, how can we get the points very quickly? Yes, Claire?
Just switch the y and x.
Yes, okay, because we already got the table, right? So very conveniently, we just switch them. So -3, 0 is gonna be 0, -3, right? We don't need to figure out like a domain or the input restriction like this, because the inverse is a parabola here, right? We can see a x squared minus 3, right? So we don't have to pick points for that anymore. We just use the original table and then switch x and y. Okay, and make sure you think about how to curve it the right way. Okay, so I'll let you guys complete the graph as well and raise your hand when you finish this graph. I need to lower your hands first, okay. Okay, so please raise your hand if you also finished the second graph. Are you guys so fast now? Okay, so can I have Susan? Can you try to draw on the screen what the second graph look like?
Yes.
Okay.
Um,
Okay, 0, -3, right? Good. Oh, 1, -2, I made a mistake here, right? I missed a negative sign. Yeah, 1, -2, good. Yeah. So root 2, -1. Go root 3, 0. Okay, how do you make the curve then? Okay, perfect. Very good. Okay, I'll just trace your graph. Yeah, good job. Okay, and Eric, can you help us draw the symmetry line then? Okay, Eric, can you draw the symmetry? Wow, okay. Okay, like a laser beam. Okay, very good. Yeah, that's correct. Okay, I'll just trace over you. Okay, so if you are drawing the symmetry line because it's not part of the graphs, okay, you can use dashed lines. Okay, that's good. So last part, okay, in the homework, you will also be asked to write the domain range for both functions, okay? Domain refers to X, okay? Range refers to the Y. So usually it's easier to figure that out by looking at the graph, okay? So for the f of X, you can make a chart like this, okay, for the homework. So f of X, you look at the red graph. The X values for all the red points, right? All these are the red points, right? Are starting from -3, right? If you look at the table, right? Because of the restriction, it needs to start with -3. So we can say the domain is X greater and equal to -3. Okay, so domain is describing what kind of X can be used, right? For the points. And then the range depends on the X, right? Because range is the Y. Y depends on your input. So you can get the range by looking at the picture now. Okay, what does the range look like? Nick, what do you think the range is?
X must be,
Range should be Y.
I mean, Y must be greater than or equal to -3.
Why is it -3? How do you know it's -3?
Because it's like X -3.
Okay, if you look at the graph, right, where is the beginning of the original graph? Which place?
-3.
Can you circle it on the screen? Where is the beginning place of the red graph?
Here.
Yeah, okay. What's the coordinate for that point?
X is -3, Y is 0.
Yeah, but we are looking for the range, right? Range, you should be focusing on the X or the Y.
Y.
Yeah, so the Y is starting from,
Oh, I thought we were doing the other one. So Y starts from 0.
yes, okay. So start from 0 and then it keeps on rising, right? For the original, we're on the original, right? Okay, so how do we describe the range now?
So Y is greater than or equal to 0.
Okay, so based on the domain range, is telling the people that where the graph is. Okay, the graph is on the right side of -3 and also above 0. Okay, so the X is about left and right. The range, the Y is about above and below. Okay, so it's describing where the graph is. Okay, so that's for the original. Now we are moving on to the inverse. So I'll let you try the same thing. Okay, look at the graph and describe the domain range. Okay, once you've done that, you can raise your hand. For the green one. So remember, domain is the X, range is the Y. And then you think about the points on the green graph, okay? Describe what kind of points, what kind of X are being used for the points, and what kind of Y's are being used for the points. Okay, please raise your hand if you finish the table. Okay, Callum and Nick, do you have any questions?
Oh, I'm done. I didn't raise my hand though.
Okay. Okay, Jocelyn, what's your domain for the inverse? Jocelyn, yep.
Is the domain
I didn't catch you. Can you say again? What did
is
you
the domain like 0?
So X, right? X what? Domain is X, and then what did you say? Can you say it one more time, Jocelyn?
Sure.
Because I didn't hear.
X
Mhm.
X is greater or equal to -3.
So same as before.
Yeah.
Okay, what about your range? What's your range?
Range is greater or equal to 1.
So Y greater or equal to 1. Is that your answer?
Yeah.
Okay, can you tell me on the graph, okay, on the green graph, where is the starting of the green graph? Can you circle it?
There.
Yeah, very good. Okay, so for that point, what's the coordinate? What's the coordinate for the point? Do you know where that point is? The number?
3, -4.
Are you sure? The one I circled. Three -4 will be here though. Okay, 1, 2, 3, 1, 2, 3, 4 will be here. That's 3 -4. I'm talking about this one, the starting point of the green graph.
Oh, that one is 0, 3.
Yeah, okay, we're interested in that. I think you thought I meant the comma, right? Okay, so 0, -3. So what's the x value?
0.
0, right? So the graph will start from 0 for x. Okay, and then it will go to the left side or the right side. The graph. Every point is it getting closer, like more to the left or to the right?
To the right.
Yeah, you see the arrow I'm drawing, right? It's moving towards to the right side. So it will be starting from 0 and then moving towards to the right. So if it's moving towards to the right, is it getting bigger or smaller?
Bigger.
Getting bigger, very good. Okay, so that's your domain. Okay, domain is describing the x. So x is getting bigger and bigger than 0. Okay, so domain should be greater and equal to 0. Understand?
Yeah.
Okay, now what about the range? Can you try to think about the range again? Range, it starts from range is the y values, right?
Yeah.
So it starts from what value? What's the y value for?
-3.
Yeah, and then does it get bigger or smaller?
Smaller.
How do you know? Look at the graph. It starts from -3. What direction is it going? Does it go higher or lower?
Higher.
Getting higher. So is it getting bigger or smaller?
Bigger.
Bigger, okay? So going higher or going to the right, those are getting bigger, okay? So how do you write the range? Y has to be what?
Y is greater or equal to
Equal to, where's the starting point?
-3.
Yes, okay? So you just need to find out where the starting point is, okay? Understand, Jocelyn?
Yeah.
Okay, yeah. So now if you look at the table here, right? Do you see any connection between the inverse and the original? Angela, what do you see in the table?
The inverse is just the domain of fx but flipped. Like they switch around.
Okay, yes, okay. Domain range, they flip it around. Right? It used to be -3 for the domain, right? Greater than equal to -3, it becomes the range of the inverse. But the variable, you still have to use the same one, right? Domain is always x, range is always y, okay? So remember inverse, the meaning of it is to switch x and y. So of course, your domain range has to be switched as well, right? So if you know this pattern, in the future, right? Once you figure out the domain range for original, then you know right away what the inverse is, okay? Or the other way around. Sometimes they could like take away part of it, right? They will say, okay, I give you, I cross this out, right? So I'll give you this, want you to fill out the blank, right? What should go inside the domain of the original? Okay, so based on what you have, you already know, okay? So let's go. We have one more question to cover here. Anyone has questions so far? Okay, So last one I want to do is page 10. Okay, we won't do page 9 today. It will be next week. Okay, today we're gonna do page 10, question 12. So far we cover the linear, right? Straight lines, what inverse looks like will be linear. And question 9 is a radical, right? It looks like a parabola. So by the way, since we mentioned about parabola, this green graph is only half of the parabola, right? For the parabola, it's like a U shape, right? This one. We have x squared minus 3, right? That was our function, right? But then because the original, because inverse depends on the original, because the original only has half of it, right? The upper half, upper half. So when you get the inverse, you only get the right side half. Okay, so if they give you a original that's the lower half, then the inverse will be the left half. Okay, so left and lower, like brothers. Okay, upper and the right side will also like brothers. Okay, so they are symmetry to each other. Okay, so just keep that in mind. So you only get half of it if you get the original only half. Okay, so the next one that we have, question 12. Okay, everyone go to page 10. This one is a rational function, right? So let me highlight that. So find the inverse, same thing, okay? And then we'll graph both on there, okay? This one we won't do the graph, okay? Because we didn't learn too much about graphing rational. We'll just get the function out, okay? This one a little bit tricky to get a function, but I'll let you try first, okay? So find the new functions. Follow the 3 steps. Okay, you can raise your hand when you're done, okay? So this one, original. So make sure you make a start here, okay? And this one is a little bit tricky to figure out the inverse, okay? Many people got stuck while trying to find the inverse. But we'll see, okay? Maybe you guys can figure it out, okay? How to find inverse here. So please raise your hand when you finish. I'll do step 1, okay? Step 1, pretty easy. Just write it as y first. Okay, so please complete step 2 and 3. I'll do step 3 on the side. Okay, has anyone able to figure out the inverse function? Okay, we have 1 so far. 2, 3. Okay, pretty good. Okay, we got 3. Okay, so far we have 7 people done. How's everyone else doing? Anyone got stuck? Okay, Chris, what's your step 2?
I switch the x's and the y.
Yeah, so what does it look like after that?
X equals to 2y minus 1 over y plus 1.
Yeah. Okay, so once you switch that, the reason why this one is a little bit difficult is you have more than one y, right? Like before, you just have one y to isolate. Now you have 2 y's there. All right, Evan, what do you think? How do we start on this one? Step 3, to isolate y.
I'll stuck on step 3 because I didn't know how to do it.
Okay, so stop at step 2.
Yeah.
Okay, okay. How about Lily? Did you do anything after switching x and y?
No, I couldn't figure out.
Okay, let's get some hint, okay, from those who raised the hands. Okay, Nick, how do you start?
Switch, so like multiply both sides by y plus 1.
Okay, so we try to get rid of the denominator, okay, because having a denominator there looks very difficult. We just do something called a cross multiply. Okay, I'm just gonna copy it over. And then we grab the y plus 1, cross multiply, right? The left side can look at it as x over 1, okay? You cross multiply to the left side. So then it will look like x times y plus 1, and then 2y minus 1. Okay, so Evan, do you think you know what to do after that? Evan,
Yes.
what can we
Maybe.
do?
You can just plug in the x.
Yeah, expand.
Yeah.
Yeah, okay, go ahead, right? See what happens after that. Okay, give you more times. Okay, try to isolate y. So the first obstacle is to cross multiply, right? If you didn't think of cross multiply, you'll get stuck. Okay, Susan, can you tell us what you got after this step, after cross multiply?
I got xy plus x is equal to 2y minus 1.
Yeah, equal to 2y minus 1. Very good. Did you do anything after that?
Yes, I moved the negative 1 to the other side.
Okay. And how do I write it out?
Xy plus x plus 1 equal to 2y.
Okay. Anything else after that?
And then divide both sides by 2.
Okay. So then the 2 cancels out, you're left with y. Is that what you got?
Yeah.
Okay, but you still have the y on the left side though, right?
Mm-hmm.
So this is not completely isolate. Isolate means only have one y on one side. You shouldn't have any more y on the other side. Okay, so you're pretty close. Okay, so let's keep thinking. Okay, what should we do? Angela, what do you think? Did you get to this step, Angela?
No, I just got to here. I'm not sure what to do.
Okay, let's get another hint, okay, from someone else. Philip, what did you do after this?
Move the negative 1 over.
Okay, how do I write it out? Can you tell me?
X, y plus x plus 1
Mm-hmm.
equals 2y.
And
then you divide both sides by 2.
isn't that what Susan did? Did you stop there?
Yeah.
Okay, so right now it looks like y is by itself, but you still have a y on the other side, okay? Your goal is to have only y on one side, right? No other y at all. Okay, so this one won't work, okay? But good try. Anyone else did differently? How about,
Jason,
yeah, Daniel?
I think I know how to do it.
Okay, how do we do that?
So I first added 1 on both sides.
Okay, can you tell me how to write it out?
So it's xy plus x plus 1 equals 2y. And then
Okay,
I subtracted xy on both sides. So it's x plus 1 equals 2y minus xy.
okay.
Uh, and then I factor a y out on the left. Oh, no, on the right.
Okay, so on the right side, they both have y. So we will take out factor the y out. So can you tell me what to write?
So it's y and then times 2 minus x.
Mm-hmm. And then
And
x.
then,
Okay,
yeah.
let's stop there. Thank you very much. Good job. Okay, so this is the key step. Okay, you need to factor. Make sure you put triple star there. A lot of people got stuck here. Okay, because don't know what to do, right? You got 2y minus xy, but then they cannot combine together. So what you can do is to factor the y out. Okay, so what's happening here? Okay, let me erase this one. So what you can do is you see the left side has y, right? Xy. And then the right side also has 2y. Okay, and then you have the green one. The ones that doesn't have the y. Okay, so look at this line again. So what's happening is we put all the terms that has y together. So what Daniel did is he moved the xy to the right, at the same time moved the -1 to the left. Okay, so we can do them both at the same time. Okay, xy to the right side, the -1 to the other side. Okay, then you get the next line. And then don't get stuck there, right? Take the y out, factor. So now instead of having 2 y's, you get only 1 y. Okay, can you raise your hand if you understand the steps so far? So we are only one step away now, okay? Okay, Kaylin, Chris, and Jocelyn, do you guys get it? How to get here? How about you, Kaylin? Okay, Jocelyn, do you have any questions?
No.
Okay, so we are one step away, right? So what should we do after that, Jenny? How do we isolate the y now? We are at the start here, yeah?
The 3-star part?
Yeah. After there,
Okay.
right? We got a y outside the bracket. What do we do now?
Can we divide both sides by 2 minus x?
Very good. Okay, so that way it will go to the left side. Okay, so at the end, we just left with x plus 1 over 2 minus x. Okay, so this is our inverse. Okay, please remember this one. Make sure you look at the notes. Okay, if you got stuck again on the homework. And of course, this one has a fraction, right? So don't forget your restrictions. X cannot be what, Eric? What's the restriction here?
2.
Yeah, okay. I cannot have x equal to 2 for this one. Okay, so that's all we're gonna do, okay? So remember how to find inverse. And next we will be talking about the other page, okay, page 9. Next week we should be able to finish this chapter. And I will, we still have one more, right? One more page. It's called the square root of a function, and then we're done, okay, this chapter. So if you have any other questions, you can stay after class, and then we'll call it a day, okay? I'll see you next week.
Thank
Okay.
you.
You're welcome,
Thank you.
everyone. Have a good
Thank
weekend.
you, Jason.
You're
Have a good
welcome.
week.
Bye-bye.
Thank you, Jason.
You're welcome.